Hello, everybody, and welcome to episode 2 of the Battery Intelligence podcast. Today, I'm delighted to welcome Kiran Kumar, Director of Data Science and Analytics at LG Energy Solution Vertec. Welcome, Kiran.
Hey, Brad. Nice seeing you here.
Welcome, Kiran. Thank you for joining us. We're delighted to have you on today's episode. Many of our listeners today will be joining from graduate, PhD graduate, right through to C-suite level, and they'll be excited to hear about all the exciting projects that you have at Vertec right now. So perhaps you could give us an introduction to the battery energy storage system as a whole, and maybe an insight into the typical applications that you're involved in.
Sure. Thanks for inviting me. It's a pleasure to join this podcast. So battery energy storage, right? So we are primarily focused on lithium-ion battery storage because of variety of commercial and technology milestones it has achieved over the years. That being said, there are several battery energy storage technology out there. Some of the introduction that I give, even though it is coming from a lithium-ion energy storage domain, but some of it could be applicable to other storages as well. When we talk about battery energy storage, there is like a big classification. There is a residential energy storage, and there is a grid energy storage. At the residential energy storage, it's a very growing segment, especially when you think of integration with the EV, vehicle to grid, rooftop solar installation integration with residential storage. The application includes like a home energy usage, obviously, and provide any support when there is a disruption to the grid. And then the residential storage also could be used as a part of a distributed energy storage. When we talk about grid energy storage, which is a massive installation of batteries, nowadays we are talking about much bigger size than, let's say, 5 years back or 3 years back. Mm-hmm. So some of the application includes like grid transmission line stabilizations by utility, standalone storage to participate in the wholesale energy market, grid frequency regulations, several ancillary services. PV plus storage is one of the big things happening in the renewable energy space. Wind plus storage, there is lots and lots of potential there. The diverse energy market in the US, Europe, and other parts of the world offers many opportunities for battery energy storage as such. And with this kind of application and with the growing demand for energy consumption as well as production, energy storage is in a sweet spot, sitting in between many generation sources as well as many load characterizations. So,
yeah, very, very interesting. And curious to know a little bit more around your role within Vertec, Kiran. Perhaps you could shed a little bit more light onto your team and what exactly you guys are doing and how you fit into the wider business of LG Energy Solution.
Sure. So I'm a director for the data science team here. We are a small but growing team. We are primarily looking at a variety of data coming from the storage system. When we talk about data, it is the battery has a lot of characterizations we need to do, and we collect a lot of data from the battery packs, battery racks. It's an hierarchical design, so we get a lot of the design signals from variety of nodes, because when we install this energy storage, there are a lot of computing nodes like a rack BMS or the zone controller or a power block controller. There is an inverter, there is HVAC. So we get a lot of data from the site, and this data provides a lot of signatures on variety of things happening on site, and that requires a deeper analysis. You cannot just go with the rule-based logic. It cannot be a simple analytics engine. So my team consists of a data scientist, software engineers, data engineers, SQA, so amalgamation of various disciplines. And we work very closely with the cross-functional disciplines such as mechanical engineers, thermal engineers, electrical engineers, project engineers, and we also get involved during the contractual negotiation. And we collect a lot of data. We are sitting on like terabytes of data, and we are anticipated to go into petabytes within the next couple of years. The industry is growing at much faster pace, much faster pace, and we are trying to understand, looking at this data, the value add that we bring into the to the business. And my team is involved in day-to-day analysis of this data, conceiving of algorithm, deployment, characterization of system, performance enhancements, all those things.
Sounds very, very interesting. I guess from my side and from our listeners' side, you touched on it there around some of the complexities, but perhaps you could just go a little bit deeper, particularly around maybe share some examples on the data products and that you're working on and how they're benefiting the system integrators and the customers, if you can.
Sure, sure. So LGES Vertec is a system integrator. LGES, the corporation, is big manufacturers of batteries, lithium-ion primarily. So as a system integrator, our job is to put together the battery racks from LGES. And when we put together, it is not just slapping together. There is a lot of design consideration to be given as a part of system integration. It is every project is a unique, and every market is unique. Within USA, there are different ISOs, which is a market segments, and each one of them has a different rules how to monetize the energy storage. So, and when we install these things, we also add in a lot of intelligence at each one of these building blocks, and those intelligence comes with a lot of software development. And when we collect the data and when we look at the data, it is a very domain specific. Data in itself is useless unless you add a layer of domain to it, domain knowledge to it, and then you can extract some of the signal patterns that is very beneficial. And some of the data products could be looking at the anomaly detections at the battery level. Lithium-ion cells are great, but it also comes with a risk if you don't control the batteries at appropriate temperature and appropriate power. So the BMS does its job on site to make sure the battery racks are safe. However, when we look at the data, we find certain patterns wherein it gives us a cue as to if there is a battery degradation is happening much faster than anticipated, or if there is some potential for temperature bubbling up in some cells. We look at those signal patterns and then we alert our service team like, hey, this is something going on. We need to make sure that the system is safe. So there are a lot of coordination that goes on from looking at this data through our data products and then coordinating with the wider team. That's one example. And we also look at the lithium-ion batteries. It's a chemical pouch cells we use. And in that the material may degrade. The material reduction might happen with the lithium-ion inventory is another problem. All these things exhibit certain unique patterns that is important for us to track and support it for the on-site operation. As a system integrator, we are in the front line with the customers. They're holding us responsible for any kind of availability guarantees, any kind of performance guarantees, any warranty exposure. So it is a huge warranty exposure for us if we don't detect this kind of anomalies before it becomes a catastrophic for our business. So we do put a lot of emphasis on the safety of the system. So that's one example. Another example is how do you extract maximum energy without sacrificing the life of the battery. So when we are talking about system integration, there is thousands of battery racks nowadays we install. And when you have thousands of battery racks, you can imagine there are hundreds of thousands of battery pouch cells. And each one of them has its own brain, so to speak. To understand the characterization of this huge installation base requires a lot of complex data analysis. And we do that through deeper data science algorithms. And the intent here is to make sure that the energy that is guaranteed to the customer is available at all the time. And in order to make sure of that, it is not just the battery, but also like the balance of plant, which is something like we put together as a system integrator, such as HVAC, the auxiliary powers, the fans, everything needs to be in sync. It's like an orchestration at the maximum level you can imagine. And this orchestration requires coordination between the data and the software. And the data products is an eye and ears to what's happening with all of these subsystems. And we can identify like which is suboptimal, which is optimal, and we can tune our power distribution algorithms or trying to command certain racks to be behaving certain ways so that we can maximize the energy, again, without sacrificing the life of the batteries. So all those things is a layer and layer of complexities that comes through data products that we have designed.
Fantastic. I guess a question from my side. What would you say? It sounds like there's lots of complexities with the data, but if there was, say, the biggest challenge that the data science the data science team faces, what would you say that is?
I think at the forefront of data consumption is the data engineering effort. The data that we collect, it is from variety of nodes. The source of data is coming from different subsystems. One of the key challenges we have is synchronizing all this data. That's the biggest part. And the second part is getting a consistent data so that there is no gaps in our data streams. As much as we like to say we have a reliable data stream, there is always some gaps. So when the gap happens, how do you fill those gaps? If it is a 1 second, 2 seconds, that's not a big problem. But if it is a minutes, it could be an infrastructure issue or it could be something else going on. So that's one of the biggest source of consternation within the team. Like when we go and look at the multi-year data, there is a lot of complexities involved in making sure the data is consistent, synchronized, and wherever there is a missing data, how do you populate that data without sacrificing the actual behavior of the system or without compromising the actual behavior of the system? So data engineering plays a key role because that becomes a source for the data scientist.
Mm-hmm.
So if we are giving a bad data, that may lead to different outcomes within our algorithms, and that is not good. So our pain point is getting the data, a clean data, and high bandwidth data.
Okay. And what would typically be some of the data science models that the team are using to solve some of these issues, if you don't mind?
Sure. We use, it's not anything unique. I think that some of the industry standard models we use, it's all depends on what is the problem we are trying to solve.
Mm-hmm.
As a director, one of the things I'd like to introduce, I like to make sure that our team is not fall in love with the solution, but fall in love with the problem, so
Mm-hmm.
that we choose the right solution to tackle the problem. So there is some of the examples is we use convolution neural networks, CNNs. We use logistic regression. Some of the algorithms is purely statistics based. We use Monte Carlo data analysis for some of the sweeping of different scenarios. We are exploring LLM models, which is a lot of people are aware nowadays. LLM is getting a lot of attention, but we do see a lot of potential with LLM. Most of the data things that we are dealing with is a time series data. However, there is some, maybe 10% of the data could be 10 to 20% is non-time series. So we are trying to add intelligence combining these two through the LLM, or at least conceiving combining these two domain data through the LLM model and provide an insight to the service team, for example. That's a potential we are exploring. So these are some examples without going into too much details.
Very interesting. I have to ask the question, Kiran, from a hiring recruiting perspective, do you think that the kind of skill set that you would need, does that candidate have to come from an LLM type background? Would they have come from like an AI startup, or do you think it's a better fit for them to have come from a renewable energy domain? Do we think that maybe a manufacturer would be a better fit? Just curious to know what kind of candidates you typically look for when you are building out your team.
Yeah, that's a very good question. And we have just one step back. Our team grew from 2 people to now 13 in the past 18 months. So we ramped up very fast and we are sustaining it very well. I think it's kudos to the team and the team leads. We are working together in harmony, knock on wood. I think when we look at the candidates for filling in data scientist position or software engineer position, we don't always expect them to be having an energy system background, although it is preferable because your ramp up time would be much shorter if you're coming from an energy storage background or a wind turbine background or a PV background or even a manufacturing. There are a lot of commonality between manufacturing and some of the things we do. So this domain knowledge certainly helps the individuals to come up to speed on some of the data product architecture, but it is not mandatory. In fact, all our hires, except for one or two, most of them did not have the domain background, and we have tooled ourselves to support the candidates coming in cold feet from the domain perspective, as long as they bring in the right technical skills from the data science perspective or a software engineering perspective or data engineer perspective. I think we can bring them up to speed on the domain knowledge, and that is one of the things we. As much as we pride ourselves supporting the domain knowledge, it is one of the bottlenecks, to be honest with you, because domain knowledge doesn't come in in a linear fashion. There are a lot of use cases, a lot of corner cases that one system would be exposed to understand that, and to connect the dots. It doesn't happen in a linear fashion. It's a very non-linear process. Give or take, I think it's very common for an individual to really see through all the patterns. Maybe it takes maybe 6 months to 1 year, give or take. Not every day they will be spending on domain knowledge. It is just that the nature of work is so that to get exposed to all the aspects of the business, all the aspects of the domain, it takes some time. But when we hire candidates, we focus on if we are hiring for a data scientist, we focus on what their academic background has been, what they've done in the past, job experience. If you're hiring for with some industry experience, what they have done, have they been able to use a mathematical background or a data science background to solve the problems? Were they just using the library blindly without knowing the background? Those kind of things we like to focus on. And there are also soft skills, but without going into the soft skills part, just on the technical skills, I think if in our team anyway, we emphasize on Python-based software development, and Python data science, data analytics, algorithm development. Somebody who has gone through the trials and tribulations of ingesting the data, big volume of data, and putting together an algorithm and experimenting with it, going through the brainstorming session of if this algorithm doesn't work, what else I can explore. All those things adds to the maturity of the candidates. So we like to hire those kind of candidates who bring in that, what I call it as a micro entrepreneurship to the team. Because being in a small team, you got to be able to work independently, and also sometimes you may have to shoulder some responsibilities as the business is growing very fast, and we are asked to support so many things. Sometimes we may be doing field data analysis. Sometimes we may be looking at the data and then conceiving an algorithm to improve the efficiency of the data product. So only individuals who can be passionate about data science, passionate about learning, we try to select those kind of candidates.
Yeah, that makes sense, Kiran. And then looking forward to 2024 and beyond, you mentioned the data engineering and cleaning the data, and that being an important part from a technical aspect. But is there anything else that you're focused on around perhaps the architecture? And we've spoken about MLops as well before, and just curious as to what the priorities are for your team for this year and then beyond 2024.
Sure. So we have been working on several data science-based algorithms, statistics-based algorithms. Especially for the data science algorithms, we have taken one of the complex algorithms that we have built through the MLops food chain, so to speak, and we have been successful with it. What MLops is providing us is an automated way of ingesting the data, cleaning the data, training the model, validating the model, and then checking in the new model to the GitHub repository in an automatic fashion. It reduces the labor hours we have spent manually for all these things in a very drastic way. So we love that MLOps aspect of it. So we are going to emphasize more and more of it within the team. Some of the algorithms that we have built, validated manually, are staged now to go into MLOps. In the next couple of years, our goal is to transition all these algorithms that is showing some good results into MLOps environment and reduce the overhead of managing and maintaining that manually. That is the MLOps part of it. On the data engineer side, we have come up with an architecture in the past, but we are seeing, it's a constant evolution. Whatever you design now, 3 years down the line, you may have to revisit that, or 5 years down the line, you may have to revisit that.
Yeah.
So we are in that stage right now with respect to data architecture. So we are seeing some bottlenecks with our existing data architecture. So what we are looking with the data engineer is to come in with some good industry experience. Doesn't need to be energy. This is purely transferable skills from a different industry. Somebody who can look at our data patterns coming in, a lot of time series data, and provide us an architecture wherein it's a high throughput and reliable data source, and provide an glue logic or a glue interface wherein, whether it's an API or some other thing, wherein we can ingest, we can tap into this source and get the data from different sites, because each site is a huge volume of data, and we have a lot of sites, energy installation sites, and there is a data governance aspect of it. So we have a cybersecurity team. So we want this data engineer to work in tandem with the data governance team, and making sure that the data scientists get the reliable data. And then there is a lot of opportunities application wise. There is a lot of opportunities. Predictive analytics is one of the areas which is growing, and it's a must for a site of this. Some of the sites are like American football field size kind of installations. So when you're talking about this much of volume of installation and volume of data, so naturally we need to make sure that all the elements are coming together from data engineering perspective, data science perspective, and then sustenance of the code. So we need people who have this tenacity to not only for innovation, but also to support this through the life of the site, because some of these sites have a warranty for 20 years. So we need to come up with the deployment of these algorithms which can reliably run for 20 years. Optimization is another, it's a unique skill set. Not everybody gets trained out of the college. So this is something who has done it day in and day out, taking the software code, optimize it for either memory consumption or a speed, because some of this we are running through multi-year data analysis. And when we do that, it has to be quick. When customer is trying to run a certain scenarios and identify a weak point in the system, they don't have a patience to sit there for multiple days. So I think maximum their time span is maybe 10 to 15 minutes. So we need to produce results within 15 minutes when you're crunching through all this source of data. So we are looking at all of those aspects. Where the business is now is good, but where we are looking forward for the next 3 years, it's a huge growth we are expecting, and all these disciplines are helping us to push to that kind of an application area.
All sounds very interesting, Kiran, and I look forward to staying in touch with you over the next few years and seeing how all of this progresses. I think it's amazing that you've grown from 2 to 13 in such a short period of time, and that there's so many exciting plans ahead. And I have to say, I'm blown away by the product and what you guys do. So kudos to you. I always enjoy hearing about everything that you're doing. So thank you very much for taking the time. If there's anything else that you'd like to add to the call that I've forgotten, please feel free.
Sure. Thanks for that encouragement there. I think you have supported us during the past 2 years. I look forward to work with you for some of the key positions. If there is one thing I do want to, for a future aspirants or future candidates, is energy industry is growing. It may not be as cool as a Silicon Valley industry, so to speak, but energy industry is growing at a faster pace. We need a lot of smart people in this industry to solve some of the climate issues, and the only way we can get there is through hiring right people and who are passionate to solve. You need not be a climate junkie, you need not be a green technology enthusiast, but if you bring in your skill set to solve day-to-day problems with the data science, I think that in itself will add up to the resolving some of the climate tech issues we are feeling right now.
Completely agree, and thank you for adding that, Kiran. Yeah, thank you so much for taking the time, and I'm sure that everybody listening will be on the same page with you in terms of tackling those climate issues. And the importance of growing the energy industry right now. So yeah, thank you very much. And to everybody else, please join us for episode 3 next month. More details will follow shortly on LinkedIn, but thank you everybody for joining us today. Thank you again, Kiran.
Thank you, Brad. Have a good
Bye.
one. Bye.